Hi there, I'm Hao, and this is just another solving random code problem. So we have Pastum 4. I suggest you to solve the Pastum 1 to 3 first before trying it. So we are given a 3 with a depth smaller than 5, right? Represented in the 3-digit integer. So um, it is a tree, but it doesn't have a node like we used to have, right? Like a class node where we have the left and the right attribute, right? But no, everything is represented by 3 digit integer here, right? So we have the 3 digits, right? The unit gonna be the value, right, from 0 to 9, right? The 10, right, gonna be the position, which is 1 to 8, right? And the last one gonna be the 100, gonna represent the depth or the level. Right? So for example, for 3, we are at level 1, right? Position 1, and then value 3, right? For 5, we are at we are at level 2, right? And then position 1, right? Position 1 on level 2, value 5, right? Same for 1, level 2, position 2, right? And value 1. So that is how we represent the node, right? Um, and then what do we have to do? We need to return the sum of all paths from the root toward the leaf, right? So uh, this is one path, so 8. This is one path, 4. The answer is 12. Right? So the sum of all paths from the root to the leaf. Right. So, okay, first thing first, we don't have the left and the right attributes, right? So from a random node, how do we get to each children, right? So let's say we are at 113 here, right? 113. How are we supposed to get to each children, right? So we know that the children of a node will always be on the next level, right? So we always increment this by 1, right? Um, and then the position gonna be the current position of the node, right? Is position multiplied by 2, right? So 1 multiplied by 2 is 2, right? So on level 2, position 2, right? And uh, position 2 minus 1, right? Position 2 minus 1. So this will be the left, right, child, and this will be the right child, right? So that is how we're gonna get to the children, right, from a random node. We will increment the level, right, and then multiply the position by 2, right, and then minus 1. We get the left and the right child. Um, so yeah, we can use a depth first search to solve this. Right, we can style at 3. Right, and go to 5. Right, 5 don't have a child, right? There's no left and there's no right. So we need to be able to check whether or not the child exists, right? A node exists. So to do that, right, we can keep track of the level and the position, right? because the level and the position will always be unique, right? So we can have a map, right? And where the key gonna be the level, right? And the position, right? And it's gonna be the current value, right? The sum up to um sorry, this gonna be the value, right? And as we iterate, we can keep track of the sum, right? Here we have 3 and then 5 and then 1. So before we even iterate to the 3, we should iterate through uh, the we should iterate through the nums array, right? To the nums array, and then store the node, right? We store the node by storing the level, right? In that case, we can have a constant lookup in the hash map, right? Right. So we're gonna have what? You're gonna have so 113, right? So we're gonna store 1 1, right? Right. We can divide the number, right, by 10 to get the level and the position, right? And this is gonna be the value, right? So 2 1, right? On level 1, position 1, we have value 3. On level 2, position 1, we have value 5, right? And so on and so forth. Okay. So we have our node here, right? Our node here, because we don't have left and right, right? So the unique thing about the node that represented in this way is the level and the position, right? Which is the 10th and the 100th digits, right? So we saw a map here, so we can have a constant lookup later on. Okay. So yeah, as we iterate through the node, we're gonna keep track of two things. We're gonna keep track of the key, right? The key and the sum, current sum that we have. What is the key? The key gonna be the key gonna be the key in the map, right? Like the level and the position. So this is our array 113, 215, and then 221, right? Right. We can start out at the first node, right? 113. So the key gonna be 11, of course. Right. We're gonna keep track of the key and the sum, right? The key gonna be 11 for the first node, right? So like imagine when you run a depth first search, right? Usually we're gonna pass in the root initially, right? And the root here gonna be the key, right? Which is like 1 1. Okay, so 1 1. And then the sum gonna be you can start out at 0. Right? Okay, so left first search, right? I mean we process the left first, uh the right, and then the node. So we go to the left, right? So when we go to the left, right, we need to of course we're gonna add the value, the node value, the current node value, right, which is 3, right? So we get the node value by so okay, so how do we know what is our base case? Our base case is where the node is null, right? So the node is null is also equivalent to the key, right? Not in the map, not in the map, right? Where the key not in the map, right? So if it is like let's say 3 3, right? It is not in the map, so the node is null. We don't have this children, like for example, right? Let's say from 2 2, I'm gonna look at the children, right? Which is 3 and 4, right? And then we don't have the children in the map, which means this node is null, right? And in that case, we can return false, right? Um, yeah. So when the node is null, which means the key is not in the map, right? 1 1. So in this case, 1 1 is in the map, so which means we have the node, right? So we can extract the level. We can get the left and the right children, right? By doing some math. So the left going to be 2, and on the next level, 2 2, and then 2 1, right? 2 2 and 2 1. right? 2, 1 is on this side, and then 2, 2 is on this side for the right child. And then yeah, when we go down to the children, we need to add the value of the current node. So this become 3. The sum going to become 3, right? And this is going to be the new node. Right? When we go down here, right, it's going to become 2, 2, right, which is the current node, and the sum, which is the current node value, right? So we keep going, right? We rush to the left. So when we go down another level, we have 3. If you go left, right, we're gonna have 1 multiplied by 2 minus 1 is 1, right? And then this one is 3, 2, right? The sum gonna be 8 here. The sum gonna be 8, right? And because we don't have 3, 1, right? So we're gonna return right? We're gonna return back up. And we're gonna return back up, right? Same here. We don't have 3, 2, so we just return back up, right? And actually, because we don't have the left, right? We don't have the left node, and we also don't have the right node, right? So we know that, okay, it is a leaf node, right? And because since it is a leaf node, we will return back up, right? But before we return, we need to add to the sums, right? Right? We need the sum of all we need the sum of all path, right? From root to leaf. And since we already got to the leaf here, right? We're gonna add 8 to the total sums. Right? Sum equal to 8 because this is a leaf node, right? And current sum is 8. Okay, so now we return back up again, right? And look at the right side here, right? So we continue, right? So it is 3 and 3, right? And then 3 and 4. Right? We don't have these 2 nodes inside the map, so it is it is a leaf node, right? Because it is a leaf node. Sum is 4 here. We're gonna return back up, right? And before we return, we need to add it to the sum, right? And the current sum is 4 plus 8 is 12. Right? So that is our general approach there. Okay, so we're gonna have our sums. So this will be our the total sum. Each sum gonna be the sum from the path root, right? From the root to the leaf. You return at the end, right? And then we need the map, right? Like I said earlier, so we need to store the node, right? And we store the node by storing the key and the value. So this is the level and the provision, right? When we divide it by 10, there's a map C is equal to the value. And the value is gonna be the num mod 10, right? The num here is like 113, right? If we divide it by 10 and float it, we're gonna get the first 2 number, the first two digits, which is the level and the position, and the value is gonna be 3. So we build our map there, right? And after that, we can run the default search, right, to calculate the sum. And we start out by passing in the root, right? And what is the root? The root is just gonna be nums at in the number at index 0, right? 113. So that is 11, right? Divided by 10. Right, the sum will start at 0, of course. So when we have the EFS, we type in the key and the sum, right? So when the root is when the node is null, right? We will just return 0, right? In this case, No mean no. Yeah, so here, no mean the key is not in the map, right? We just return, actually we can just return. We don't have to return 0 here. And now we have to extract the level from the key, right? The key is the level in the position, right? So we can get the level by making the key divided by 10 before that. So the position is gonna be the key mod 10. So we extract the level in the position here, right? From the key. Right? And we can get the left and the right, right, by doing level of left one multiplied by 10 plus, right, 2 multiplied by position, right? It is left actually, minus 1, and it is right. Right, left and right. Right, so from the key, again, the node is represented via the key, which consists of the level and the position. Right, we extract the key, we extract the level and the position from the key, and then calculate the left and the right child. Right? We just go to the next level and the position multiplied by 2. We need to update the current sum, right? The current sum is the sum in the parameters. Right? The current sum from the root up to the current node, right? And what is map? The map at the key, right? Because we are storing the value here, right? The key. After that, we're gonna check if it is a leaf node or not, right? So the leaf node mean there's no left and right here, right? So left not in map, and then right not in map, right? In that case, it is a leaf node, and because it is a leaf node, we are done, right? We have to return, right? And before we return, we need to add the sum to the current sum, right? Right. The current sum here means the sum from the root to the leaf, right? This is the leaf. And the sums plural here is the sum path, right? Of all paths, right? Um, yeah, if it is not a leaf, right? And we can just continue. After we add the value of the current key to the current sum, we're gonna go to the left and the right, right? Recursively. Uh, yeah, passing in the left and the right and the current sum, like that. And yeah, that's pretty much it. Yeah, so and yeah, this a little bit hard to imagine here because we don't have a node. Like as usual, we are use like 3 digits to represent the node, right? So like the node, again, the node gonna be like like the key in the hash map, right? We need to store it in the map like this, so we can have a constant lookup, right? Yeah, we evaluate the position, and then we start out at the root, right? Which is the first number, right? Divided by 10 to get the key, the key, right? The level and the position, right? Right. If node is null, right? We return. Otherwise, right? We extract the level and the position from the key, calculate the left and the right child, right? Update the current sum, and then recursively going left and right, passing in the updated sum, right? If we see a leaf node, we return immediately and add uh, the sum to the total sum, right? Okay. Thank you for watching.